Now let's take a look at some of our special special products. Squaring a binomial. So square binomial is a special case of the product of two binomials when they're the same. It's important to note that the power rule of exponents does not apply when we have more than one term. A lot of students will mistakenly think that this equals a squared plus b squared, and it does not. Now, recall that when something is being squared, we're multiplying it by itself. And if we applied the distributive property, we see how we end up getting the following terms. But keep in mind, through commutative property of multiplication, AB and BA are the same term. So when we combine them, we get 2 times A times B. This gives us our pattern that we can use as a formula when we are squaring a binomial. A plus or minus b squared always gives us a squared plus or minus, matching this sign, 2 times a times b plus b squared. And we can use this to go ahead and square binomials much more quickly rather than expanding it out. Because we could always write this as x plus 5, and then go ahead and use the distributive property to multiply and combine like terms. But if we follow our formula, a squared plus or minus 2ab plus b squared, then what we can do is actually substitute these values in for a and for b and evaluate them much more quickly. We would have x squared, we're going to match the sign, 2 times x times 5 plus 5 squared, giving us x squared plus 10x plus 25. We can do the same thing here. X squared minus 2 times x times 9 plus 9 squared. X squared minus 18x plus 81. We can even do it if we have multiple factors within a term. 3x squared plus 2x times 2z plus 2z squared. 9x squared plus 12xz plus 4z squared. 4m squared squared minus 2 times 4m squared times 3n plus 3n squared. 16m to the fourth minus 24m squared n plus 9n squared. 3 squared plus 2 times 3 times 2a plus b plus 2a plus b squared. We're following the same formula, even though it's a little bit more complicated in how it's written. We can still apply it. So here we have 9 plus 6 distributed gives us 12a plus 6b. And here we can apply the same rule again. So for just this subset, we'll go ahead and do the same thing with a squared plus 2ab plus b squared. So we'll have 2a squared plus 2 times 2a times b plus b squared. So then the whole thing equals what we have here. If you get stuck, you can always revert to distributive property, but recognizing the pattern with a square binomial not only speeds up your multiplication, but it's also going to come in very useful in later sections. Let's take a look at another special product. When we multiply the sum and difference of two terms. If we have the same two terms in our binomial, but we're adding one and subtracting the other, when we apply our distributive property, what happens is the multiplication of a times negative b and b times negative a cancel out. And so all we're left with is a squared minus b squared. So as long as we notice that we have that pattern, then we don't need to worry about the second or the third multiplication because they're going to undo each other. When I multiply x times 3 and 3 times x, those multiplications are going to cancel each other out. So the only thing that I have to really worry about is the x times x and the 3 times 3. So we have x squared minus 3 squared. X squared minus 9. 4y squared minus 1 squared. 16y squared minus 1. X squared squared minus 2y squared. X to the fourth minus 4y squared. 3m squared squared minus 1/2 squared. 9m to the fourth minus 1/4. Here we have a much more complicated binomial, technically a trinomial, but again we have the same terms here, a and a, b and b, 1 minus, 1 plus. So we can take 5x minus 2y squared minus 1 squared, a squared minus b squared. Here we can use our shortcut for squaring a binomial. 5x squared minus 2 times 5x times 2y plus 2y squared. We'll bring down this minus 1. 25x squared minus 20xy plus 4y squared minus 1. Now this last one's not a special case. It's just multiplying 3 polynomials together. And so I just wanted to add it in here. Here what we have is 3 binomials being multiplied. So we'll focus on the first multiplication. We'll apply our distributive property. Combine like terms. And then we'll bring down the other polynomial. And then from here, we'll repeat our distributive property. And then we can combine our like terms.